Okay, let's dive right in. We are about to go on a mathematical detective story, a hunt for a hidden pattern that's woven into the very fabric of numbers. We're going after the biggest unsolved mystery in the entire field, the secret of the primes.
So you probably remember prime numbers from school, right? 2, 3, 5, 7, 11, and on and on. The numbers that can only be divided by themselves and 1. I mean, on the surface, they seem pretty simple. But what if I told you that the way they show up on the number line is one of the most profound and stubborn puzzles in all of science?
And this is the heart of the mystery. For centuries, primes have just seemed to pop up with no rhyme or reason. They look totally chaotic, and yet mathematicians are absolutely convinced that underneath all that randomness lies a breathtakingly precise and elegant order, kind of like a secret music. The quest is to find the sheet music.
To crack this code, you're going to need a special tool, a key that can translate the random-seeming sequence of primes into a completely different language, a language where the hidden pattern might just decide to show itself.
That tool is called the Riemann-Zeta function. Now don't worry about the crazy formula. Just think of it like this. A function 0 is just an input that makes the output become 0. It's like finding the exact key that makes a machine go silent. When Riemann used this idea on the primes, he found that the locations of these zeros held a real secret. So this is the crucial point. If we can create a perfect map of where all these zeros are, we can basically reverse engineer the whole process. A map of the zeros would give us a map of the primes. The chaos of the primes is somehow perfectly encoded in the order of the zeros. The mystery has just been transformed. And this leads us to the single most famous, most valuable, and most sought-after guess in all of mathematics. A simple idea about this map of zeros that has obsessed the greatest minds for over 160 years.
So, picture this. It's 1859. A German mathematician, Bernhard Riemann, is studying this weird landscape of zeros. He calculates the first few of them, by hand, mind you, and he notices something extraordinary, something so simple it was almost ridiculous.
He predicted that every single one of the important zeros, the ones that mathematicians call non-trivial, would fall perfectly onto a single straight vertical line. I mean, imagine an infinitely long tightrope, and every important data point lands squarely on it without exception. He called it the critical line. And that's it. That is the legendary Riemann hypothesis. It's this clean, elegant statement that suggests there's a profound, hidden harmony in the universe of numbers. A universe that, at first glance just looked like pure chaos.
Now, why does any of this matter? Well, because as another mathematician, Helge von Koch, showed way back in 1901, if Riemann's hunch is right, it doesn't just tidy up a mathematical chart. It gives us an incredibly precise formula for how prime numbers are distributed. It would turn our blurry, fuzzy understanding of primes into a crystal clear map.
Okay, so the hypothesis is on the table. But in math, a really good guess just isn't enough. You need proof. So let's look at the incredibly clever ways mathematicians have tried to crack this case wide open.
The first approach is kind of like a search and rescue operation. If you can't prove all the zeros are on the line, maybe you can prove they aren't anywhere else. So mathematicians have been slowly, painstakingly cordoning off huge areas of the number landscape, proving them to be zero-free zones. And you can actually see the progress here. Starting way back in 1899, the known zero-free territory has just steadily gotten bigger, with major breakthroughs in 2015 and even new results in 2024. They're literally boxing the problem in, shrinking the space where a rogue zero could possibly be hiding. But the next clue in our story comes from a place nobody, and I mean nobody, expected. A field that seems to have absolutely nothing to do with pure numbers. It turns out quantum physics might just hold a key.
Okay, this is where things get truly mind-bending. The Hilbert-Pullier conjecture suggests this almost impossible connection. On the right, we have the positions of the zeta function zeros on that critical line. On the left, you have what are basically the specific energy levels of a quantum system. The wild idea is that the list of numbers for both is exactly the same. The pattern of prime numbers might literally be a reflection of quantum physics. So while some mathematicians are hunting for clues in physics, others have taken a much more direct approach. What if you just check? What if you use the insane power of modern computers to start hunting for these zeros, one by one, and see if a single one strays from the line? Yep, this is the brute force method. Now, it can't ever prove the hypothesis is true for all infinity zeros, but if it finds just one that's off the line, the whole thing comes crashing down.
So the hunt was on.
By 1982, computer scientists had found the first 200 million zeros, every single one, right where Riemann said it would be. A pretty staggering number, but oh, we are just getting warmed up.
Just about 2 decades later, thanks to way faster algorithms and just raw computing power, that number absolutely exploded. By 2004, the first 10 trillion zeros had been checked and confirmed, all of them perfectly on the line. The evidence was becoming, well, astronomical.
And the latest major milestone from 2021 takes this even further. Using a special method, mathematicians didn't just check, they rigorously proved that every single zero up to an incredible height of 3 trillion is exactly on the critical line. No doubt about it for that huge chunk.
So, with all these brilliant strategies, all this overwhelming computational evidence, where does the case stand today? What's the final verdict on the greatest mystery in mathematics?
Here's the case file summary. We have what any court would call overwhelming circumstantial evidence. Trillions upon trillions of zeros have been checked, and they all have a perfect alibi. They're right there on the critical line. Now, one counterexample has ever been found, but, and this is the killer, we still don't have that one final definitive proof that covers every single zero all the way out to infinity.
And so, after more than a century and a half of relentless searching, the case remains open. The Riemann hypothesis, for all the mountains of evidence in its favor, is still unproven. The ultimate secret of the primes is still just out of our reach.
Which leaves us with a really fascinating final thought, doesn't it? Is this incredible pattern in the primes a deep, fundamental truth about our universe that we can one day prove? Or is it just an elaborate cosmic coincidence that holds true for the first few trillion cases we've been able to check, with some exception lurking just beyond what we can see? The search continues.